Hi guys, this is Stoichiometry102, part 2, and what I'm talking about here is percent yield, and these are notes for my general chem classes. And the homework is still the Stoichiometry 2 worksheet, and we're going to start off with a little mental exercise, and that is, I'd like you to think of a time in your life when you got less than what you expected. And I will give an example. Let's say scoring lower on a test than expected. So let's say you go into a test, you're super confident, and you take the test and you expect to get 95 points out of 100 or whatever. And your grade comes back and you actually get 72 points. And by the way, this has happened to me in several of my college classes. And it's always a little bit disappointing, but that's okay. So we can compare what we expect and what we actually got. Excuse me. Like this, we can do the actual amount over the expected amount times 100, and that's going to give us the percent of what we expected to get that we actually got. So if our actual was 72 points and we expected to get 95 points, and we multiply that times 100, that's going to give us the percentage of what we expected, or sorry, the percentage of what we actually got compared to what we expected. So this is 76%. Okay. So I'm going to connect this to stoichiometry. So the first connection to stoichiometry is that the answer to a stoichiometry problem like when you do grams to grams or liters to liters or grams to liters, any of that. So the answer to a stoichiometry problem is always an expected amount. Okay, and this has a scientific name. It's called the theoretical yield, where yield is talking about how much something is produced or how much of something is produced. And the other thing we want to remember is that in reactions, not all the reactant reacts to become product. So this decreases the amount of product produced. And gives only a partial amount of what was expected. Okay, and so this is called the actual yield. So what's actually made is called the actual yield. So if I was going to connect it back to my example here, the actual yield would be the 72 points and the expected yield was 95 points. So this would be like our answer to a stoichiometry problem, where this is what actually gets made in lab. Okay, so we want to connect this to what we're talking about up here, and that is percent yield. So if we look at this expression, percent yield is equal to the actual yield over the theoretical yield. Times 100. And I will often use this in place, the word expected in place of the theoretical yield. So if I want to do actual over the expected times 100 equals my percent yield. So I always remember that as American Eagle. A over E times 100 equals the percent yield. Okay, so we're going to do an example calculation. And sorry for the camera work here, you guys. An example calculation, and we'll say for our example, and I'm going to switch papers. Go back and pause that as needed. So here's our example. I'm going to say for the reaction of aluminum with oxygen to make aluminum oxide. And this is going to be 4, 3, 2. And we'll say if we start with 15 grams of aluminum, and actually produce, let's see, 15. We'll say we produced 40.2 grams of aluminum oxide. We want to know what is the percent yield. Okay, so we want to know if we start with this 15 grams of aluminum and actually produce 40.2 grams of aluminum oxide, what's the percent yield? Okay, so we need to identify that this is a percent yield question, and we're going to use actual over expected times 100 equals the percent. And we're actually given one of these parts in the question, and that is the actual is given, and that's going to be our number here, 40.2 grams. And that's of aluminum oxide. And then what we need to know is what's the expected amount. So that's kind of a question mark first. Times 100 is going to give us our percentage. Okay, so this expected amount is pretty easy to get to. We're going to do a stoichiometry calculation. So we're going to start with 15 grams of aluminum, and we're going to convert it to moles first. And then we're going to, of course, use our mole ratio. And on the bottom is going to go our aluminum, and on the top will go the aluminum oxide. And then we would finish with the molar mass of aluminum oxide. And that's going to get us to our expected yield, which is like if everything reacted and everything was perfect, this is what we would get, 101.961, which would be analogous to my 95 points. Divided by 4, divided by 26.982. Okay, I'll do that one more time. Let's do 101.961 divided by 26.982. 4. Okay, so let's go back really quick and change this number. Otherwise, my example's not going to make any sense. Sorry. We're going to say that that number is instead is 4.2 grams instead of 40.2 grams. Okay, so this comes out to be 28.3 grams, or expected. If I had this at 40 grams, we would have had a greater than 100% yield. Okay, so this number goes right there, and this is 4.2 for the record. So I'm just gonna rewrite this down here, 4.2 grams of aluminum oxide made over 28.3 grams expected, times 100. So we'll get 4.2 divided by 28.3 times 100, and that gives us 14.8% yield. Okay. So we want to just take away from this actual over expected times 100 equals the percentage. And you can also solve for the actual if you're given a percent and an expected amount, or a stoichiometry problem to get to the expected amount. So just remember that actual equals percent times expected over 100. That's just doing a little bit of baby algebra there to solve for the actual. Okay, sorry about the number change mid-notes there. And that's it. Okay, I hope you guys are doing good. Email me if you have any questions. We can do a Google video hangout and clear anything up that you get stuck on. And